So you know you have to graph out the line 1. You have to graph out this, and you also need to graph out this. Yeah. So what's your step 1? Gradient. Okay. Then Y-intercept. Okay. So how can the so your thinking process is okay. I need to get the gradient and the Y-intercept. So by the way, the small letter m represents the gradient, and then the small letter c represents the Y-intercept. So you don't have to U-intercept. You don't have to write the full form out. Just make use of the small letter m and c. Okay. So how does the gradient and the Y-intercept help you graphing the line out? So okay, so let's start with line 1. So this will get you, okay, so you need y, okay, so you start off with y minus 4 equals to x. So you have to do a transformation. So the transformation should look like y equals to mx plus c. So you need to transform it into this format. So you bring the minus 4 over, right, to the right. So what you end up with is y is equal to x plus 4. Okay, then you compare your this y equals to x plus 4 to y equals to mx plus c, and you realize that your m is equal to 1 and your c is equal to 4. So how does this gradient is equal to 1, c equals to 4 help you graph out this line? Or does it help, or it does not help? So you know the gradient is 1 and the y-intercept is 4. Can you graph this out by knowing the gradient and the y-intercept? Yes. Okay. So your yes is okay. By the way, there are two ways we can graph this line out. So number 1, we can use the GeoGebra app. GeoGebra. One of them is the GeoGebra app, and then the other one is a manual. Okay, manual. Okay, so I think you have no problem graphing the no problem graphing this line out using the GeoGebra app, right? Why? So let me just launch this GeoGebra app. Okay, so can you see the GeoGebra app interface, which is here? Okay, good. So can you see that you can actually key in the equation into it, and then you will get the line out. So what's the equation now? I mean, what's the line 1 equation? This is the equation, right? Y is equal to x plus 4, right? Okay, so basically line 1 is given by this y equals to x plus 4. So can you, so basically what you need to do is you just have to key in y equals to x plus 4 and then enter, and then this is the line already. So this is your line 1 already. Okay, so with the GeoGebra app, you can quickly get the line 1 out by keying the equation into this app. So after today, you have no problems graphing any equation using the GeoGebra app. All right, you shouldn't have any problem graphing any equation using the GeoGebra app. All you need to do is just key in this equation or whatever equation you are given into this box, and then press enter, and then you get the graph. Clear? So okay, yes, okay, good. So you have the GeoGebra app on your iPad already? Can you key in and see if you, I mean, yeah, can you key in and see if you can get a similar graph here? You can split screen. Yeah, I am on computer. Oh, okay, you are on computer, then even better, right? Even better. If you have your iPad next to you, you can just bring out your iPad and then quickly key in and then see if you can get something similar to mine. Even better, yeah. You don't need to do a split screen. Here, please, please, please. All right, welcome back. So yeah, try to key the y equals to x plus 4 into this box, and hopefully you get something similar. And please tell me whether you get something similar. Yeah, you get something similar. So how do you check whether you get something similar or not? So you just focus on the y-intercept, because okay, so let me get this. So I can go to the toolbar and then I can choose the pen. So next time when you graph any equation using the GeoGebra app, you go to the tool here and then you choose the pen tool here, okay, so that you can write on this. So basically what you need to focus on is this is the y-intercept. Can you see the y-intercept is 4? Is equal to 4? Which is here, this point. Okay, so C is equal to 4, right? Okay, and then it hit the this is called the X intersection point. Of course, the question is not asking for the X intersection point, but I just want you to know that this is called the X intersection point, this point. So this point is given by -4, 0. So do you get this? Do you get the y-intercept is C equals to 4? And then do you get the X intersection point at -4 and 0? If you get that, then you are right. Okay? Do you get these two? Correct? Hello? No response? I only... One only? What do you mean by one only? You only get this? You don't get this point? The 4 here? Can you how okay, now okay, can you take a screenshot and I mean take a screenshot of your iPad and then you send it over by email so I get to see what do you get on your side, because just now you show me through the camera is still not very clear, or maybe you need to zoom in a little bit. Okay, there is a zoom in and out here. Can you see? Zoom in, then you need to zoom out. So you need to zoom in and out and see if you get whether you get what I am getting here. If you still don't get it, then just take a screenshot of your iPad and then just send it over to me through email. Then I get to see what you are looking at. Actually, if you are using a computer, using Zoom on your computer, you can actually share your screen through there is this application called Share via iPhone or iPad. I'm not sure if you know about it. But never mind, just WhatsApp me, yeah. Email, yeah, please. All right. Yeah, you are getting it, what? Never mind, let me just share it over. You are getting the same thing. Can you see here? Can you see? Okay, good, thanks. Okay, so using can you erase the yes, please? Can you erase your handwriting first? So yeah, thanks. I'm going to get this. So yes, so next time, right, you just make use of this GeoGebra app, and then you get to graph any equation. All right. So, but of course, ultimately, you need to learn how to use a graph paper to graph. But for the time being, just learn how to use the GeoGebra. Okay, if you look at this, right? If you look at this, I hope it's big enough. Is it big enough on your side, on your screen? Okay, good. So this is where this area is where you key in all the equation. All right. So this is your line 1 equation. Line. Okay. So later on, we are going to key in our line 2 here. Okay. Later we will key in the line 2 here. So this is how do you get to this page is choose the algebra, choose this calculator mode. Okay. This is called the tool mode. This is called the tool mode. The tools mode is for you to like when you want to write on it. Later you will see. I will demonstrate to you. So if you look at this, right? This is your y-intercept. Can you see? Can you not see? This is your y-intercept, c equals to 4. Okay. And then this is your x-intersection point. This is your x-intersection point. And the x-intersection point is given by this format. The format is bracket, -4 and comma 0. By the way, the y-intercept, right, is a value. So the y-intercept is a value, which is 4. So what I want you to distinguish is the difference between y-intercept versus x-intersection point. Okay, y-intercept is a value. X-intersection point is given by this format. Okay, so please differentiate. So in this case, the y-intercept is c equals to 4, which 4 is a value. While x-intersection point is given by this format. So this format is -4 and 0. So can you see the difference? Okay. Can you see the difference? If they ask you for point, if they ask you to point, you need to give it in this format. But if they ask you for the y-intercept is a value. So you just give it a value 4. Okay, you're not supposed to give it you're not supposed to give this 0, 4. No, wrong. So this point is 0, 4. This point is 0, 4. But we are looking for the y-intercept, and y-intercept is a value, so c equals to 4. Okay, so this is difference. I want you to take note and give the correct answer dependent on the question. All right. Okay, good. So you get the line, and then this is the line. All right. So the next step is you can get the line 2. So can you key in this line x plus y equals to 6 to your you don't erase the first one, just add this x plus y equals to 6 onto the same graph on your GeoGebra app, and then you are supposed to see 2 lines. Okay, so once you get that, please email that over. So once you have emailed me, let me know. Are you done? So add this, key this x plus y equals to 6 to the same graph. Okay, good. Not yet. Okay, good. So let me just wait. I asked you not to delete the first one, right? You have deleted the first one. I asked you to just add to it. There is a reason why I asked you to add to it. Okay, can you add the first one back to it? Can you add the first one back to it? I want the two of them to be together. Because over here it says what? Draw both line 1 and line 2 on the same graph paper. So I want it to be same graph paper. I don't want it to be separate. So can you add it back? It's okay. The whether you put this one first or this one second, it doesn't matter. I want to see both on the same GeoGebra app. Can you do it now? Yeah. And then send it over. Done. Are you done? Should be quite fast. I just key in these two inside only. What is taking you so long? Are you facing any problem? Wi-Fi? What's this? Wi-Fi? Slow. Slow Wi-Fi. You mean the sending over of the thing is Wi-Fi is slow? Wi-Fi is slow. You just key it in, take a screenshot, email, unless you are telling me the email is still on the way. Seems like the email is still on the way. I still haven't received. But just now the other two so fast. Okay, receive, yes. Okay, good. So let me just get it to my list. All right, got it. Thanks. Okay, so this is the one. Okay, this is the one. So let me just crop it out and just get it to this. Okay, so you can see what? You can see this is your line 1, and then this is your line 2. Okay, so you just have to like key your line 1 and line 2 into the box here, and then you get your line 1 and line 2. And if I'm not wrong, okay, sorry, if I'm not wrong, okay, by the way, this is green color, right? So can you see this is green color? So your line 1 is actually your line 2 is actually y equals to 6 minus x. Okay, and then this is the gray color, so this is, or black color, this is y equals to 4 plus x. And then what you need to do, you need to label this is your y axis, this is your x axis. Okay, so if you want to use the GeoGebra app to graph any equation, this is the way. All right, this is the way. Okay, but I think for this question, there is something you need to take note. There is something you need to take note over here. It says draw both line 1 and line 2 on the same graph paper. Okay, good. So you must draw line 1 and line 2 on the same graph paper. Okay, so I need to see 2 on the same graph paper, not separate. Okay, and now they say given this range for x, given like x start from -2 and then end at 3. So you need to follow this range. Okay, so let's go back to your graph and see how you can fit. So it says x start from -2 and then end at 3. Okay, so if you look at your this completed GeoGebra graph, right, you see that your x start from what? Okay, your x start from -6 to 12. Can you see that? While the given range for x is actually -2 to x, -2 to 3. So what you need to do? So you start from -2, which is here. For x is here. So you start from here, and then you end at 3. And 3 is in between here, in between the 2 and 4. So it's about here. And then anything out of this range, you have to discard. Discard means remove. So what you will end up with? You end up with this. So you have to do the cropping. So I could just I need to do a crop. So I need, sorry, no. So I need to do a crop. So now -2 is here. And then, no. Done. So you are supposed to show this. We just make it smaller. Yes. So you are supposed to show this. So just tidy up tidy it up a little bit. Are you clear? So this is what you are supposed to show. So this is y equals to 6 minus x. And then this is your 4 plus x. Okay, so for this question, you have to, it's not free range. Okay, there is a range for x. So can you see this is -2 and then this is 3. So you have to have this is called the lower limit, and this is called the upper limit for x value. And you cannot go out of this limit. So therefore, you will not see anything beyond. There is nothing beyond. There is nothing beyond. Okay, there's nothing beyond the lower limit, and there is nothing beyond the upper limit. Okay, so if you want to use the GeoGebra app to do this question, this is what you need to present. Okay, this is what you need to present. Are you clear? This part, this part is what you need to present if you want to use the GeoGebra app to do this question. Are you clear? Okay, yeah. So because of the range in X, that's why you need to do the cropping. Okay. So next, the question asks what? The question asks draw line 1 and line 2 using graph paper. Okay, good. Find the intersection point. Okay, find the intersection point and then label this point. So if you look at it, where's the intersection point? Ah, this is the intersection point. Can you see this is the intersection point? Intersection point. So this is the intersection point. And what is this point? This point is your, so this is 1, comma, and then this is 5. Okay, so it's 1, 5. Okay, so that's how you complete the question. Okay, so mark it and then label. So this is the way you label a point. 1, 5. Of course, you need to write it next to the point. Yeah. So 1, 5. Yeah. That's how you label the point. All right. So that's how you complete this question. Okay, clear? So we have completed question 1, or this. We have completed this. Okay. Okay, good. So what if you cannot use the GeoGebra app to draw? So what if you cannot just key this in and then get the line out? What if you cannot? So with the GeoGebra app, we can do it like, oh, we just key in y equals to x plus 4, and then we will get the line out, right? So what if you cannot? You don't have this GeoGebra app in your exam, right? You don't have this luxury, right? Then what to do now? Any idea? Draw what? What you need to draw? Yep, you need to draw, but how to draw? That's my question. How to draw? Any idea how to draw? Coordinate. Yep. So how do you start? Yep, connect coordinate. So how do you connect coordinate? I mean, in order to connect coordinate, you need to have coordinate first. Or you need to have the points first. So how do you get the points first? How do you get the points? Let me get the graph out to you. So how do you get the points out? How do you get the coordinates out? So let's start off with the y is equal to x plus 4. So how do you get the coordinates out? So they say the range is -2 to 3. So how do you get the coordinates out? Any idea? You give yourself a table. Because if you give yourself a table, the table is going to give you the x and y value. And the x and y value, they will give you the coordinates. So what is the first x value you give? -2. So if you give -2 into this, what do you get? You get 2 for y. And then you go to -1. So you give -1 into it, you will get 3. You get 0, you get 4. You give 1, 5, 2, 6, 3, 7. That's it. So you are going to get coordinates already. So this this table of X and Y values will give you the coordinates. So the first the first point is actually your first point is actually -2 and 2. So you come to -2 and 2. -2 is here, 2 is here. So that's your first point. -1 and 3, -1 and 3. Yeah. 0 and 4, 0 and 4 is here. 1 and 5, yeah. 2 and 6, yeah. 3 and 7, yeah. Okay, so it looks like I have to because of the I have to accommodate from -2 to 3 for the X values. So it looks like I have to actually crop out. That means I have to crop out a bigger graph paper. Okay. Then after that, just link up the points. And then this is going to be my so looks like the 7 is actually slightly above, which is here. Okay, which is here. All right. So that's how you get your, this is your y is equal to x plus 4. So 7 should be here. So 7. So let me extend this. So 7 is somewhere here. Yeah, here. Not the lower one. Yeah. So it looks like I need to adjust it a little bit more. Adjust it a little bit more. It's a bit off. Now it's good. Okay, good. Now it's good. Okay. So this is your y is equal to x plus 4. Okay. All right. And then because of the range -2 to 3, so I stop at -2. I stop at 3. I don't have anything beyond. Okay. I don't extend the line out of the lower limit. I don't extend the line out of the upper limit. Okay, so this is my y equals to x plus 4. So how do you get the line 2, which is -x plus 6, right? Let me double check. Minus x plus 6. Yeah. How do you get this out? Given the same range, because you are supposed to draw the two lines on the same graph paper. So how do you get this? Same thing. Give you another set of x and y value. So -2, give it to it. So -2. So -2. So it's +2 plus 6. So -2, you get 8. Give it -1. So now instead of -2 is -1. So it's 7, 0, 6, 1, 5, 2, 4, 3, 3. All right. So this table will give you this. Then the above table is, it describes the y equals to x plus 4 instead. This two, it describes this. This two, it describes this. So you need to use the table correctly. All right. So once you have this, the -2, 8, then -2 and 8. Where is it? Okay, looks like yes. Due to the limitation of my graph paper here, so looks like I need to crop out a better graph. Yep, I can quickly just get it from here. So when it comes to graphing, you have to plan If you don't plan, you have to plan. If you don't plan, you have to plan. 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 You have then not so good. So now I think I can do a better one. Okay, let me quickly do a better one from here onwards. So -2 and 2, yeah, I have to redo. -1 and 3, 0, 4, 1, 5, 2, 6, 3, 7. So this is my first line. By the way, the lesson is recorded. So if you don't know how to do a similar question next time, you can always refer to this recorded video for some ideas. So this is your x is equal to x plus 4. Okay. Then now I'm going to do the -2 and 8. -2 and 8 is here. -1 and 7. 0, 6. 1, 5. 2, 6. No, 2, 4. Yeah. I almost read wrongly. 2, 4. And then 3, 3. So once again, link it up. Okay, so I choose a different color. So this is your y is equal to minus x plus 6. All right. So this is how you so label your y, label your x-axis. So this is how you sketch without using the GeoGebra app. Are you clear? And then label the intersection point, which is here. This is the intersection point. And then this is your 1 and 5. Yeah. Okay. So this is the manual method. Are you clear? Are you clear or not? Okay. So the manual method requires you to start with the table. Okay. So the first table here describes this, the first line. The second table here describes the second line. So the first table is going to give you the first line. And the second table here is going to give you the second line. And then once you have your second and first line on the same graph paper, and then they intersect here, and then you just have to mark it and label it. Okay, and then this one looks exactly like your this the image you sent me. Okay, so if you have forgotten how they look like, so I can quickly just demonstrate to you. They look exactly the same. So the other one is minus x plus 6. So I just crop it out and compare it, and let you see for yourself. Okay, so I park it side by side. So the thing you need to take note is how do you tell whether they are the same or not? You just ask yourself, number one, the intersection point. So the intersection point in this case is 1, 5. So this is 1, 5. This is also 1, 5. Another thing you need to take note is for the red line here, the y-intercept is 6. So for my red line here, my y is also in so the y-intercept here is 6. So the y-intercept here is also 6. Then for the y-intercept of your blue line, right, is 4 here. So this is your c equals to 4. So this is also c equals to 4. Okay, so that shows these two are yeah, exactly the same. Okay. Okay. So I have demonstrated to you. This is by the app. Okay. Then this is by manual method. Okay. So I will leave it to you. The next time you encounter a similar question, I will leave it to you. Whether you want to use the app or you want to use the manual method. In your test, in your exam, you have to use the manual method. All right. You have to. Okay. The app is for our exploration purpose. Okay, it's for our convenience, right? Okay, good. So we spend a bit of time on the first question because I really want you to know how you get the two lines out, because if you can get the two lines out, this is the main idea in this chapter. Okay, then when you look at the next one, part B is x equals to 1, y equals to 5. So remember just now, the intersection point is 1, 5. And by the way, this is your x coordinate, this is your y coordinate. And similarly, if you use the substitution method, then you have the same solution. So can you see that they all have the same solution? So that's the conclusion. The conclusion is I want to show you whether you use the graph method, or you want to use the calculator method, or you want to use the substitution method, they all give you the same solution, which is x is equal to 1, y equals to 5. Okay? Okay? So the conclusion from this question 1 is same solution, whether you use the graph method or calculator and substitution. I hope you realize that. Okay, I hope you realize that. You realize that? Oh, no. Yes or no? Hello? Okay, good. So in fact, right? So since we are talking about the use the substitution method to solve, right? In fact, just for your knowledge over here for this question, let me just give you another flavor, how you can actually solve this question. Okay, you were using a substitution. Basically, you did this. X is equal to -4 plus y, and then the other one is x 6 minus y. So you do the substitution method. I'm not going to use the substitution method. I'm going to use the elimination method. Elimination method. I'm going to show you what is the elimination method here. So can you see that this is your equation 1, this is your equation 2, this is minus y, this is plus y. And in fact, if you use equation 1 plus equation 2, right? Can you see that x plus x is 2x? These two you add together is 2x. And then these two, if you add together, they cancel each other. And then after that, the right hand side, if you add together, you get 2. Therefore, your x is equal to 1. So if your x is equal to 1, then you put it back into one of this. So your x is equal to 1. Then you sub x is equal to 1 into x plus y equals to 6. So this is 1, y equals to 6. So y equals to 5. So this is the elimination method. Okay. So if you use the elimination method here, right, you can actually solve the question much faster. Okay. So this is called the elimination method. You eliminate the y in this case because they happen to be opposite to each other. One is negative y, the other one is plus y. So it happened to be opposite to each other. Once you add them up, they eliminate each other. That's why I can quickly get 2x is equal to 2. And then x is equal to 1. All right. So if you don't know this method, okay, I have demonstrated this method to you. And hopefully from today onwards, you start to use this method. If you see opportunity, and there is an opportunity here. All right. Good. Next, this question. This question is a question from one of my students. So she's doing this already. The coordinate of S. So coordinate of S here. Okay, very good. And then the gradient of line QR. So the gradient is M. Okay. So gradient of QR. So you are showing what? 3, 0, you are showing the point. They are not asking for the point. They are asking for the gradient. How do you get the gradient? Any idea? Gradient of QR. Where's QR? QR is here. So what's the gradient? Can you remember? What's the formula for gradient? M is equal to, oh, by the way, there are two ways to find M. One of them is Y is equal to mx plus C. And then you read from it. And in this case, you are not given the Y equals to mx plus C for QR. So this way cannot for this question. So what is the other method to find gradient? Can you remember? Can you remember? Rise over run, right? According to your school, is rise over run, right? Yep. According to your school, is rise over run. But for me, I would prefer the formula. So what's the formula? So what's the formula? This is from your school. Then what's the formula from me? If you remember, can you write it down here? Can you write it down here? If you remember the formula to find gradient. Forget. Okay, good. Okay, so yeah, so you don't remember the formula, that's why you don't get the answer. I think it's very reasonable. Okay, if you remember the formula, you don't get the answer, that is unreasonable. Okay, so therefore you have to memorize. Okay, you have to memorize. And if I'm not wrong, this is going to be the next chapter. So one of my students, they are already ahead of you. Okay, so different school, of course, they go differently. Okay, they might skip you are doing algebra, right? At the moment, you are doing algebra, right? In school. 这是什么 near 这是什么 near linear. Okay, linear. Sorry. Linear. Okay, you are doing linear equation, right? Okay, so linear equation is equal to okay, what is linear equation? Linear equation Y equals to mx plus C. So in fact, you are actually doing this already. Are you doing Y equals to mx plus C? Or you are doing something else? No. So you are not doing Y. Okay, but anyway, linear equation, when you do the linear equation, the more advanced type of linear equation, you are actually doing Y equals to mx plus C. So I will see that if you don't have any holiday, then soon you are going to do this part. Okay, so we just Hari Raya holiday, Vesak Day, Good Friday. But anyway, Hari Raya 2 days, Vesak 2, Good Friday 2. But anyway, if you have 2 months to go, then you are going to have, like, you just need to minus 8 days out of 2 months. But anyway, you will have to reach this topic, because one of my students, she's already doing this. So you are supposed to do this soon. So the formula for the gradient is actually y1 minus y2, x1 minus x2. How do you memorize this? You just take one pair of x and y minus the second pair of x and y. That's the meaning of it. So in this case, you just write down, this is your x1, y1, this is your x2, y2. Then you just put in the value. Y1, 4. Y2, 0. X1, 3. X2, 5. So it's 4 over negative 2. So negative 2. Okay, so the gradient for this is negative 2. So I write down MQR is negative 2. Okay, then for the gradient of PQ, which is here. So my Q, I already have the x1, y1. So this is the my x2 and y2. So I'm going to use the same formula. M So I'm doing PQ. So y1 minus y2 and x1 minus x2. I'm going to use, so y1 is 4 minus y2 is 4. Oh, in fact, I don't have to care about what is x1 and x2 already. You know why? Because 4 minus 4 is what? 0. 0 minus anything is 0. So I know that the gradient is 0 for PQ. Okay, so that's how I get the gradient. Okay, good. So once again, like I say, they ask for the y-intercept. Y-intercept is a value. So you don't give it in a point form. This is the point format. So QR, where is QR? QR is not 5 and 0. No. Y-intercept. Y-intercept, you're supposed to see what? You're supposed to see the y-intercept here. You're supposed to see this. Okay, so your QR is here. If I need to add on to it, so your QR is here. So you need to extend QR until it hit the y-axis. Okay, so if you extend QR, it hit the y-axis here. So this is your y-intercept for QR. So this is 8, this is 9, then this is about 10. So y-intercept for QR is 10. So I use C to represent y-intercept is 10. And then if you look at your PQ is here. So what is this point? This point is 4. And you're not supposed to give it in point form. Y-intercept is a value. So CPQ is a 4. Okay. And then now, I think you can get the answer already for F and G. So the function that describe QR. So QR, so is Y equals to MQR X plus CQR. So basically is the gradient of QR and the y-intercept of QR, which I have already found here in the previous steps. MQR minus 2. So y is equal to minus 2 x. CQR is 10. So this is the function. Similarly, you need to find a function that describes PQ. Okay, y is equal to MPQX plus CPQ. Why I give PQ and PQ? I just want to tell myself I need to find the gradient of PQ, and then I just need to find the y-intercept of PQ, which I have already found previously. So MPQ, where's MPQ? Here, 0. CPQ, 4. So if you simplify this, you get y is equal to 4. So that's done. Okay, so the function. Okay, so that's how you get the this is how you get your all the answers for this. Okay, so you need to be very careful what they look for. If they ask for the y-intercept, you better give them the value. You give them the value, okay? You don't give them the point form. This is the point form. No, you give them value. And then you make a mistake here, the y-intercept of QR. The y-intercept of QR, you should read the y-intercept. The y-intercept, which is here. This is your y-axis. Just now you read here, right? This is your what axis is this? This is your x-axis. And they are not interested in the x-axis. They are interested in the y-intercept. Therefore, you need to extend the line and then it hit the y-axis at 10. All right? Okay. So seems like you have some difficulty understanding the this topic, but it's normal at the start. But going forward, I hope you get more comfortable with this these graph questions, because I still see you have problem graphing the lines. That's the reason why if you have problem graphing the lines, then you don't know how to read the lines. It's reasonable. Okay, but after today, after this lesson, I hope you get more comfortable and you get more well versed in it. Like you are much better in it. All right. Okay. So next, which is this question 10. So once again, this question is from my student. Okay, so she's doing this. So this is one of her holiday homework. Okay, holiday homework. Okay, good. So if you have your holiday homework, you can share with me, right? So you share with me, I also share with my other students. Okay, so we just learn from each other. Okay, so by learning from each other, I think we all benefit. All right, so that's the goal. So during a science practical lesson, a hot test tube with temperature. Okay, basically over here you have you are doing an experiment, and then you have this test tube, and then after burning it for some time, and then you leave it to cool down, right? So cool down means you start from a hot temperature, and then temperature comes down. So here, if you read here, right? Okay, time is X minute. So this is 0 minute. 0 minute is 80 degrees Celsius. Okay, and then after 2 minutes is 70 degrees Celsius. How do you get it? You put it into it. You put it into this. So can you see that this table actually gives us what? Gives us the X and Y coordinates. So with the coordinate, we can start to have points. So with the points, if we link it up, we have the line. And this line is your Y is equal to negative 5X plus 80. Can you see how things link together now? Can you see how things link together now? So you compare this question to our first question here, which is discussed here, which is here. Okay. So first we start off with what? We start off with the equation, line 1, and then we get our table out, the X and Y table here. And once we get the table, we get the points out. And once we get the points out, we link it up, we get the line. So similarly, that question here. So this is the line. I mean, this is the equation. And then they guide you. In this question, they guide you. Okay. Question 1, the question did not guide you. Over here, they guide you. They start with the table first. So once you get this table out, right, then over here, use the scale of 1 cm for 1 unit on the axis, and then 1 cm for 5 unit on the y-axis. So now you need to graph this out. So to graph this out, you need to get the graph out. So looks like I need to, okay, because the question says what? The question says X is 0 to 10. So I don't need the negative value for X at all. So that's why I try to get rid of the negative side of the X value. And then for the Y value, I know that I start from 80, 80, 70, 60, 50, 40, and 30. So over here, doesn't look like I can get the 80, right? Okay, but I think I can do something about it. Okay, I think I can do something about it. So let me just do a better job here. Okay. Okay. So let me see settings. Yeah, I go to settings and yeah, looks like, yeah. Can you see? I go to settings and then I come to this. They ask me to define my this the range. Okay, so they ask the X minimum. So in fact, I don't need but the minimum point is actually 0 to 10, right? So the minimum point is 0, yeah. And then maximum is 10. Okay. And then for the Y, For the Y is, let me just look at the question. So Y minimum is 30. Can you see? Y minimum is 30. So instead of 30, I put 0 lah, better. So I put 0. So the max is 80, I remember. So I give myself some allowance. So I put 90. Okay, good, done. So back to the graph. Can you see? It's nicely done here. So I just need to crop this out. So if you want to use the GeoGebra app, this is the way lah. But of course, if you tell me you don't want to use the GeoGebra app, then fine with me also. Okay, good, done. So I get it out already. So if I remember it, okay, let's not try to get it from my memory, because I think sometimes my memory fail me. So I just get it to the question. So just plot 0 and 80. 0, 80 here. 2, 70. 2 is here. 70 is here. 460. 460 here. 650. 6 is here. 50 is here. Ah, this point is wrong. So it's okay. So I need to be very careful. 460 is here. Okay, good. So it's 840. 8 is here. 40 here. And then 10. 10 is here. 10. What's this? 30, right? Okay. Okay. So I need to link it up. Okay, looks like it's slightly off. Okay, slightly off. So I'm afraid that this might not be my 10. This might not be my 10. Looks like this is my 10. Okay, good. So let me just come back to this. Let me just zoom in a little bit. Yes. Can you see? My 10 is actually here. So if you make a mistake, your line just cannot line up one. You see? If you make a mistake, right? You just can't line them up all. So that's the benefit of doing a graph. If you make a mistake, right, you cannot line up all the points. So when you cannot line up all the points, that means wrong. Okay, when you are wrong, redo. You cannot force your way. So I'm just demonstrating to you. You cannot force your way to get the to get what you want. You must really follow. Okay, if you are wrong, just accept it and then just redo it. Okay. So for this, let me just do a better job. Okay, let me crop this out again. So never compromise on accuracy. That means don't relax, or don't be serious. Okay, be serious and don't compromise on your accuracy. Accuracy is important. If you compromise on accuracy, that means basically you know that you are wrong, but you just try to force it. It doesn't work. So let me redo it. Okay, now it's good. So the first point, 0, 80. So I'm redoing it, 0, 80, 270, 2 is here. This is 2. So 460 here. No, 460 is here. This is 460 is here. 650, 650 here. 840 here. 1030 here. Okay. Yep. So now I have the full scale. Okay. So when you do graph, you need to have the full scale. If you don't have the full scale, redo. Okay. Either on GeoGebra app or on your graph paper. On the graph paper, you just redraw. So now I can link it up. See if I can link it up. If I can link it up, that means, yeah, I'm right. If I cannot link it up, that means I have to do it again. All right, I can link it up nicely. So this is my y is equal to minus 5x plus 80. All right. So over here, what it means is you are given the range 0 to 10. So basically, I need to show 0 to 10. This is my upper limit. And then this is my lower limit. And I'm not going to show anything beyond. So you can see I never show anything beyond. Meaning I never extend this line out. No, I stop at 0. Okay. And over here, the same thing. I never extend this line out. Okay. I stop exactly at my upper limit. So I have nothing beyond. Okay. Nothing beyond. Okay. I have nothing out of the limit. So that's what this is the range. Okay. And then over here, I say 1 cm for 1 unit on the x-axis. So let me just 1 cm for 1 unit on the x-axis. Yeah. So basically over here is 1 cm. If you are using a ruler, here's 1 cm. So 1 cm. 1 cm, 1 unit. Okay. 1 cm all the way to 10. And then over here say 1 cm for 5 unit on the y-axis. So 1 cm for 5 unit on the y-axis. So it means 2 cm for 10 unit. So meaning this is 2 cm. And this is 2 cm. So 2 cm, 2 cm, 2 cm, 2 cm, 2 cm, 2 cm. Done. Okay. So on this paper, of course, you must be wondering, hey, are you telling me this is 2 cm and you are telling me this is 1 cm? It doesn't look like it makes sense. Yeah, I agree with you. It does not make sense. Why? Because just now what I did, just now I crop it out already. I still do the zoom, I do the zoom in and out, Just now I try to adjust, like bring it up and down, just now. That's why it kind of like make my scale off. Okay. So, but when you do it on a graph paper, right, you cannot drag it up and down. That means you cannot pinch, you cannot pinch or scroll up. You cannot. All you can do is you once you have written the scale down, it's fixed already. But for me, I can actually drag it up and down. Just I can drag it up and down. Okay, so that's the thing I want you to take note. Okay, but overall, the graph should look something like this. And if you want to follow the scale, you need to follow the scale. Like for the y-axis, this is the y-axis, this is the x-axis. For the x-axis, it should be 1 cm 1 unit. For the y-axis, is 2 cm 10 unit. Okay, so next. Then it says the value of y when x is equal to 5. So you need to read the value of y when x is equal to 5. Okay, so x is equal to 5. So where is your x is equal to 5? X is equal to 5 is here. So you just go up this point. So what's the y value? Use a ruler. So what's your y value? Hold on, let me just click on this. Okay. Yeah, good. So this value, just read it off the graph. Okay, so looks like it's in between 50 and 60, so should be 55. So the y value is equal to 55. Okay, so that's how you get your value of y when x is equal to 5. So x is equal to 5, y value is 55. That's how you read this point. Okay. Next, the gradient of the graph. So how do you get the gradient of the graph? Very simple. Gradient is equal to y1 minus y2, x1 minus x2. Okay. According to your school, you use rise over run, but I prefer the formula. So I use the first set of x and y minus the second set of x and y. So I just use this. Okay. So my y1 is 30. So it's 30. My y2 is 40. My x1 is 10. My x2 is 8. So minus 10 over 2 minus 5. So that's the gradient. Okay. Done. Next. If a fan was used to cool the test tube, describe how the gradient of graph would change, decrease. No, one word is not to describe. Actually, this is the very interesting question. So what do you think? So if you have a fan to help you to cool the test tube faster, right? Basically, that's the chemical reaction. It will cool the test tube faster, right? With a fan. So cool the tube faster. So this is the English part. It will cool the tube faster with the fan. Meaning what? If you try to plot it out, if you try to plot it out on the graph, so at 0 minutes 80. So if you use the fan, what's going to happen? So when it reach, let's say, the time for the tube to, okay, so the tube will finally cool down to the room temperature, which is 30 degrees. I assume the 30 degrees Celsius is the room temperature. So if you study physics or chemistry, right? When things cool to the room temperature, when they stay the same, they call it the equilibrium state. Equilibrium state. Have you learned this term before? Equilibrium state means they are the same. So if they reach the equilibrium state, then there is no change further unless you heat it up or you cool it down further. Okay, so if you use the fan to cool the tube faster, meaning what? Instead of using 10 minutes just now, so now you use, maybe it really depends how fast is your fan, right? So you know that you will use less time to cool down. So you start from 80 degrees for the test tube. Now you use less time to reach 30 degrees. So imagine you use 7 minutes to reach 30 degrees. Here's 7 minutes. So 7 minutes, you get to cool to 30 degrees already. Then you just link up these 2 points. This is what you start with. This is what you end with. Then you just link up these 2 points. Then you just look at this gradient. So this is your new gradient. I use M new. This is your gradient, which is -5 just now. So what do you think? What is your gradient now? Is it -6 or -5 or -4? So what do you think? Make a guess. Your new gradient for this new line, do you think is -6, -5 or -4? Without doing any calculation. I don't think it's going to be the same, right? Right? The gradient shouldn't be the same, right? What's this? No. Okay, so what is, okay, if the gradient is the same, what is going to happen? If you have the same gradient, the line will look like what? So basically, this is what we discussed last lesson. If you have the same gradient, your line will be a, can you remember? If you have the same gradient, the line will be what? Can you still remember? The line will be parallel. Okay? If you have the same gradient, the line will be parallel. So this one, -5 is out. So you're not going to get a parallel line. So now, then you have to decide, will this gradient be -6, more negative or less negative? What do you think? Is it going to be like -6 or -4? You just look at the slope. You look at the slide down. So your slide is here. Let me try to give you a slide here. How come I cannot get the slide up? Funny. Okay, good. So originally, this is your slide. Okay. Now, this is your m equals to -5. Now your slide is this. Let me just get it over. Now your slide is this. So you compare these two. You compare this. Let me just write down. This is your m equals to -5. So what do you think? You just compare this slide 1 and this slide 2. So can you see that slide 2 is more angled? The slide here is more angled compared to this. More angled means this is a more steep slide. Then this is more gentle. This is more gentle. This is more steep. So when the slide down is more steep than the previous one, so your m is going to be more negative or less negative? It's going to be more negative. Okay, more negative signals a very steep slide. So therefore, how do you describe? You just describe like what I have explained to you here, using the knowledge, but you need to put it in English. Okay, so a lot of students fail to answer the last question correctly. Okay, so the way you describe is with the fan, okay, the tube can be cool faster. You write down the phenomenon first. Can be cool faster. So what was the meaning of this? So this means it takes shorter time for the tube to reach 30 degrees Celsius. Yeah. Okay. I choose 7 minutes just now is to demonstrate to you. It can be 6, it can be 6.5, it can be 8. Okay. It really depends how fast your fan is blowing. But definitely it takes shorter time for the tube to cool to 30 degrees Celsius. So therefore, if you call this a slope, right? Therefore, the slope or the gradient. In fact, right? Gradient is mathematics. Slope is English. Okay. So if you want to tell people what's the meaning of gradient in real life, we call it a slope. So the slope or the gradient of the curve will be more negative. So in a way is smaller than -5, smaller than this. Okay, so that's how you explain this. Okay, you talk about the phenomenon first. What's the phenomenon? The phenomenon is it will cool faster. So cool faster means what? Take shorter time to reach the 30 degree. So this is the English part. Okay, then how do you translate the English part into mathematics? Then you need to talk about the slope. So the slope will be more negative. More negative means what? Smaller than -5. So it's definitely is -5.5, -5.6, or -6, -7. Okay, so that's how you explain this question. Are you clear? Are you clear now? What's this? Y. Okay, good. So in a way, right, I think if you have taken a look at the next assignment, I have a similar question. So before I talk about that similar question, right? So if I have a test tube here, let's say I have this is the test This is a test tube. This is some water. So you have fire. So let's say this is your fire one. So if your fire one, so your temperature is going to increase, right? Over time. So this is your time. This is your temp of the test tube. So over time, the temperature of this tube will rise, right, to a certain point, right? Then what if you have fire 2? So if you have fire 2, right, the time taken for it to reach the same temperature will be shorter because of you have 2 fires blowing at the tube at the same time. So shorter time means, okay, instead of, so let's say this is 0 minute, so this is 5 minutes. Okay, so in fact, you don't need 5 minutes to reach there. You probably need like 4 minutes, you already reach there. So that means you already reach this point at 4 minutes. If you have both fires. So I'm just demonstrating to you another scenario. So the same temperature, but shorter time. So if this gradient is 1, what do you think the gradient of this is? Is it more than 1 or less than 1? That's what you need to answer. What do you think the gradient of this line is? Is it more than 1 or less than 1? Can you pick one of them? You mean less than 1? So you are telling me the gradient is less than 1. Okay, good. So now let's look at the effect for you to understand this. So this is the conclusion part, and a lot of students miss out this. Okay, let's so we have talked about how to get the gradient, but now you need to link the gradient to some practical example. So let me start with y is equal to 1, gradient is 1, x plus 2. So this is my y is equal to 1x plus 2. Okay, let me give it a smaller gradient. Y is equal to, so just now is 1, smaller, 0.5, x plus 2. So now give it a more dramatic one. So just now is smaller, now it's bigger. I give it a 11, x plus 2. Okay, what do you see here? What do you see here? Let me get it to this. Okay. By the way, this point is quite important to take note. So this is your m equals to 1. This is your m equals to 0.5. This is your m is equal to 11. So what you observe here? You look at the slope. Okay, by the way, gradient is mathematics. Slope is English, real life. So you look at the slope. 我唔該你上一上網啦，提一開。So if you look at the slope here, what do you observe? So this is our starting slope. Okay, this is our starting slope. Y equals to 1. Okay, now compare this to our m equals to 11. Okay, and compare this to our m equals to 0.5. What do you observe? We change the color. What you observe? So this is your m equals to 11. This is your m is equal to 1. This is your m equals to 0.5. So if you look at the slope, we are talking about this is all positive. So for positive, that means for slope up. So what is the conclusion here? What's the conclusion? When your m increases, so from 0.5 to 1 to 11, what's going to happen? The slope is more steep. Or in English, harder to climb. Is it harder to climb? For this, very hard to climb, right? For this one, ooh, it's a piece of cake. Then for this one is even easier, almost flat, right? For this one, oh my God, this guy must be sweating, right? This one, m equals to 11, so steep, so hard to climb, right? So can you appreciate this conclusion? So when you have m increases, this is the meaning of m increases. The gradient increases, so it's harder to climb. All right? So harder to climb, m increases. So if you go back to our question just now, compare your the black slope, compare the black slope to the red slope. The red one is harder to climb, right? It's harder to climb. It's harder to climb than the black one, right? Right? Can you see? Yeah, you just put someone on it, you know already. Okay, this one is more. This one is more steep. So the red is harder to climb than the black one. So therefore, it makes sense for the m to be bigger than m equals to 1. Because if the black one is m equals to 1, right? So it's harder. The red is harder. So m is bigger than 1. Does it make sense? Does it make sense? Okay. So you just need to remember that this statement. Okay. M is getting bigger, then it's harder to climb. Right? The reverse is also true. Harder to climb, then the gradient is bigger. Okay. So this is about slope up. So what is the opposite of slope up? The opposite of slope up is slide down, which I'm going to demonstrate to you, which we discussed just now, the cool down by the fan. So they like to test you on this concept. So instead of okay, let me just get it over here. So instead of here to here, so I need to get the so over here I start with -1. Then I want to get a negative 0.5, and then ultimately I want to get a -2 or negative 2 is better. Okay, so to let you see the effect. Okay, done. Okay, so I'm going to insert a slide down and let you see the effect. All right, so this is your y equals to -2. Oh no, not y, m, gradient. We are talking about gradient now. So we are talking about negative gradient. So this is a slide down. Just now is a slope up. Slope up is positive. Slide down is negative. So we are talking about negative gradient now. Then this is your m equals -2, then compare to your -1. So -1 is below. So this is your -1. Okay, let me just make it smaller. Yeah. So this is -1. Change the color. Okay. So this is your -1. M equals -1. So then finally you have the last one, which is m equals to -0.5. We change the color. Okay. So what you observe here. So for slide down, which is negative gradient. So what you observe here. So you observe that when the gradient is more negative, so gradient is more negative, okay, is easier to slide down, right? So imagine someone is here. So if there is this is a more steep slope, right? Or more steep slide. So this person can slide down faster than this person, and this person, because this is almost a flat surface, this person don't even slide at all. So imagine you have this slide down, the person is here, this is even more negative because it slides down even faster, right? So if your m is more negative, it's easier to slide down. You just have to remember this for a slide down. Yes. So if you look at the cool down question just now, here, they say the thing cool faster here. So just now, this is the line. This is the starting line without the fan. And then with the fan, you have this. Okay? With the fan, you have this. So, okay, it cool down faster. So, which one slide down faster? Which one has a bigger angle to come down? This one, right? This one is easier to slide down, right? Because if you measure the angle here, this angle is much bigger than this angle. So if this angle is angle 1, so angle 1 is bigger than angle 2, so it's easier to slide down for this person 1 compared to person 2. So therefore, this gradient 1 has to be more negative than gradient 2. Okay. So similarly to this concept. Okay. When the gradient is more negative, it's easier to slide down. You see. Okay. Then for the slope up, okay, is when the gradient increases, it's getting harder to climb up. Okay. 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 So basically, they are going to test you this. They are going to test you these two concepts. When it comes to slope up, how the gradient, how the change in gradient will affect the slope. And then they will test you when it comes to a slide down, okay, how the change in gradient will affect the slope as well. Okay. If you want to experience, right, just go to a playground, probably tomorrow. Yeah, go to a playground, and then you get to experience the slide. Okay. Most of the time, children like to play the steep slide, because they want to experience the adrenaline of coming down from a steep slide. Okay, instead of a flat surface. Okay, no children like to play with the flat surface one. Okay, because no, they say no kick, no feeling. All right, so go and play at the playground and go and play some of the slides. Okay, okay. So if you go to some of the swimming complex, right? I think I don't know whether you still have the swimming complex at Jurong Lakeside there or not. So they have some of the slides, right? So this is this is the starting point. And then the slide is something like this, and then this is the swimming pool. So a lot of students they love playing this slide down because it's the slide, the gradient here is what? Very, very negative. Okay, when it's very negative, so it's very easy to slide down. And they get to what? They can experience the feeling of coming down fast. Okay, so yeah, so like the Universal Studio as well. You know, like the Universal Studio, I think you went to the Universal Studio, right? So at the start, okay, the roller coaster, right? Okay, at the start, they will drag you up. They will drag you up the slope first. Then after that, they will come down. Okay, so of course, you see, so you just need to imagine this. Okay, during the slope up, gradient increase, harder to climb. Okay, then during the slope down, which is this way, more gradient, more negative, so it's easier to slide down. Okay, so I find that this is a very good summary for you to remember. Okay, okay, so with this, I think yep, we can call it a day today, even though we might not have finished all questions. Over here, this is what you are doing, algebra. Okay, so for the algebra part, I don't think it's a very big problem. But I think we will talk about this algebra. By the way, this part, right? This part of the question, the algebra, right? Actually, is for us to do revision, because we have studied this and we have practiced this enough. Okay, so right now, we will try to focus on the graph. But you must be wondering why I still give you algebra, because I want some of the students, they want to have some practice as well. So I just give this algebra as some additional work. Okay, but ultimately we will focus on this graph. Okay, can? So next week, yep. So next week, let's see. So next week we are supposed to meet in person already. Yeah, next week we can meet in person already. April already. All right. By the way, tomorrow I think we can all unmask, right? In the public space. Do you know that? Is it tomorrow? Is it tomorrow or not? Okay, good. Yeah. So tomorrow we can unmask in the open open space. Then I get to meet you face to face next week. So please, next week, if you have any graph question, if you need to graph out, you either graph it out on GeoGebra or you graph it out on a graph paper. Okay, so you are expected to complete. Okay, if not, then we can end the day to here. Okay, bye-bye. Bye-bye, take care.